Alright, should be streaming and such. So, fix the little chat and such. And we should be on our way shortly. Blah, 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 blah. So, I guess it's time sort of for a overview, whatever. What's the real controversy here? Why all this, effort and work and conversation and bullshit. What's it all about? Yeah, okay. And so another little bit of, let's do a little historical perspective and see if we can figure out, who's obligated to do what here, and blah, 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 blah. So the Ian Gosling video, Ian has made another video, and he says, "Why are you so reluctant, Gary?" So he thinks I'm obligated to do all of the fundamental elemental physics experiments and prove, 9.8 meters per second or something. Everything has to be proven through my experiments because somehow regular physics just can't handle the job. So even though they have the billions of dollars and millions of scientists and hundreds of thousands, let's say, of laboratories, no, it's my job to prove the elemental physics, by doing all of these basic experiments. I'd say that's just kind of a bullshit thing to say, really. That's a really stupid theory. So he has done an experiment where he's claiming so all the physicists, right, all the lectures, he doesn't care that Professor Lewin overtly says, you basically have to conserve momentum, kinetic energy, yeah, so it disappears sometimes, there's extra, so what? But you have to conserve momentum. And he's overtly arguing that there's no conservation of momentum, that somehow the 1/2 mv squared is the man. Okay, so Newton, Galileo, and Descartes, again, they got right answers. That's why we know their names, is because they dissected things and showed how they worked and pointed out that this works as a conceptual, a formalization of energy in the universe, that all you really needed to know was a mass and a velocity, okay? And that would always turn out to be essentially equal to what you could call a force or energy. So these were interchangeable. Newton overtly said it. You want to double the velocity, double the force. Okay, so that was the concept. And Leibniz, who liked being different, frankly, he basically thought Newton and Descartes, who were both religious kooks, were two atheists, which was kind of funny. And he wanted the physics to be more revealing of God's perfection. And, anyway. And so he, like Huygens, thought this squaring the V was important. So they didn't have the 1/2 back then. They just had it's mass times velocity squared. That's the energy that something has. The ability to move things in the universe is based on this V squared thing. Now, the war or controversy happened because, the Newtonians basically said, well, everything we understand about thousands of years of levers and other mechanisms has to be wrong. And those things don't work the way we see them working all the time. So this can't really be true because this becomes a free energy formula. And vice versa, Leibniz said, no, MV is the free energy formula. So they didn't have any free energy formula, frankly, until the controversy showed up. So it sort of indicates that whatever the new arrival was the problem, and that what they had before did work and did answer all the questions correctly. So it's sort of a pointless conversation. So Leibniz lost and was buried as a discredited cheater. And, so in 1735 or 40, it was dug up again. They did these little gimmicky clay experiments, And because they used round objects, they could force the experiment to look like this 1/2 mv squared thing was happening, that somehow something with twice the velocity was doing 4 times the damage to something, 4 times the work, actual work. And you also had this idea that if you rolled things on a surface, that you know, the one with the twice the velocity will roll, okay, 4 times further, sometimes more actually. You know, a huge difference, okay. I mean, one velocity only gets you this little bit of roll, and but this was Galileo all over again. So this is 500-year-old physics, where Galileo explained that these are the units of time, okay, that the exposure to the gravitational friction, okay, is in these units of time, 1 unit here, 1 unit here, and that this unit is the same as this unit. So the velocity here is 1v. So instead of 1v being here in the middle, it's way out here at the quarter mark. Okay, yeah, I'm almost on the screen, right? Almost. Yeah, there's just so many little technicalities you have to take care of. So sorry about that imperfectness, but whatever. Doing the best I can, really. So this is sort of a key experiment, right? A key. So if somebody's going to argue with me, okay, they have to really argue that the half isn't here, okay? That if you actually do this experiment, it doesn't reach half the velocity 3/4 of the way down the track, and that this section, okay, doesn't turn out to be exactly the same as this experiment here. This experiment is the same as this little experiment, and this one at twice the velocity, okay, kind of obviously, all right, it's 3 units of distance, but only 1 unit of time. So if you understand, as I think Newton must have understand, that gravity is this down pressure, okay, or you could say a pulling pressure, but regardless, he understood it as being a certain amount of this pressure per a unit of time. So the faster you can go across this surface, this distance, right, if I doubled this velocity, then I would end up going twice as, you know, you could argue twice as much distance, but it will be 4 times as much distance because of the time. The fact is, it's only going to be 1 unit of time, and it's only the 1 unit of time, so it just reduces how much exposure you have to the surface because of the fact that you're only going to get 1 pressure arrow here, just 1. Let's say there was 2 units per second. So you had 2 units of pressure per second. You only get 2 units here, and you get 2 full units here. So you can understand that per square inch, this is going to get a lot more pressure than this is, because this has to spread the 2 arrows over all of this length. Okay, so if there was, you know, if I could make 7 notches with a number of notches, you'd understand the notches are going to be further apart. Same number of notches per the unit of distance. And then I've also analogized it with something I think that's just beyond any kind of rational argument, is that if I went through gravity, that is, I went past something with gravity, that all it's going to matter is this distance, that the gravity is substantial. All it's going to matter is how fast I go through it. If I go through it slowly, then I crash right in. I go a little bit faster, then it takes a little bit, you know, I get further before I crash right in. And if I go a little bit faster, okay, I get bent less and less and less. And if I go really, really fast, I'll only get the tiniest amount. I'll spend only the tiniest amount of time, okay, exposed to the gravity. I mean, it's 9.8 meters per second. I mean, why don't they deal with these arguments? 9.8 meters per second. Okay, not per foot, not per something else. It's seconds. It's about the time you spend being affected by the object. It's how much time you're exposed to it. So just like photons, I could measure it based on time. The more time I put my hand out, the more energy in terms of photons I collect. The less time, the less I collect. And so if I zoom my hand by the light, I'm in the light less time and there'll be less photons on my hand. The argument's that simple. So obviously these experiments are not telling the truth. Okay, they don't show you the reality because it isn't 4 times the work. Okay, to go 4 times the distance. It's only twice the work because you're only being affected by the gravity for 2 units of time. Alright, I can't make it much clearer than that. Alright, so let's go to his specific experiment, which, again, I claim has huge flaws in it, and he thinks is the greatest physics ever done. Yeah, so in that context, and then we have Hooke's law about springs, you know, that twice the weight is twice the pressure on the spring, twice the compression. Alright, so he's done an experiment where he's taken multiple springs. Okay. And we don't know what kind of foundation it has at all, what the springs are connected to. And the idea was he compressed them, you know, and he found that twice the compression, okay, does not. So I compress it 1 amount, okay, 1 unit of compression. We'll just say 1 compression. All right, and the object leaves with a certain amount of energy going a certain distance, and then twice the compression though only creates half. So in spite of the fact that it's supposed to be 2x the velocity, twice the compression. Now again, that's not a fact I established or anything like that. That's a fact physics established. Okay, that twice the compression is twice the weight, is twice the ability to move something at a velocity. So Professor Lewin, when he says you have to conserve the momentum, these are all experiments he did with springs. So he's basically saying the spring has to conserve the momentum. So it has to be twice as much momentum because force equals momentum. Anyway. And so that's all he got. So he was supposed to get 4 times. He got something, I don't know. You couldn't tell how precise his experiment is, so who knows what he actually got here as a result. But something like that, way short. And so I brought up some criticisms about how the multiple springs are really launching each other. They really should be tied together, and they should be tied to the base, because what you really don't want to do is launch the springs. So I pointed out some flaws. And in thinking about it, independent of him making this argument, frankly, this newest one, I haven't watched this newest video, I'm saying, well, he has the device, right? So he has a device that's basically a tube, as far as we can tell. He puts some sort of donut on here, okay, of a weight. And then he has the springs, so it keeps everything from going sideways. And we'll assume it's relatively low friction. But again, we don't know what base it's tied to, so we don't know how elastic the base is. We'd have never seen exactly what he's got here as a release mechanism or any of that stuff. So, but yeah, so we could just do the experiment in reverse. So we could drop the mass from 4 times the height and see if what kind of compression he creates in the spring, because it should technically be the same for his argument. So at half the distance, he should get twice the compression in the spring. That's his claim, right? Gravity's supposed to be the same both ways. So he's saying I drop it from 1/2 the distance and I get twice the compression on the spring. Well, let's see. If it takes 4 times the distance to get half the compression, then we guess we'll know that there's something wrong with his experimental method. And that's the thing that should be questioned. So this is 1/2 the mass. So I recall, yeah, he did 2 different masses. So half the mass and a full mass. And his claim is, okay, is that with the same spring compression, okay, the full mass goes this unit, and the half mass will violate conservation of momentum dramatically, okay, and not achieve twice the velocity, and will only get 1.4 or so the velocity. So that's his claim, that he's going to violate conservation of momentum. He's going to show that springs aren't affected by momentum, that, and you don't have to conserve it because they're basically controlled by kinetic energy. So he could do the experiment, right? He's got the equipment. Let's go ahead, do the experiment. Show us the reverse. Do the experiment in reverse from those heights and see if you get the same exact results as your lifting mechanism. Let's see if your dropping mechanism confirms, because again, gravity takes, whatever gravity takes, pushing up against it, it gives dropping down in it. So clearly he has the equipment already. So go ahead and do the experiment, would be the argument. Is confirm your own observations. Now, I'm still going to say that theoretically it doesn't fit with all of the other experiments that we can view. So you're still going to have the problem explaining it, in my opinion. Just as you can't explain the 10-ton, 5-ton thing, right? I take a 5-ton cart, I drop a 5 mass on it, I make it into a 10-ton cart, a 10 mass cart, and all of a sudden its velocity, okay, drops in exactly 1/2, which is perfectly consistent with conservation of momentum. And you say that somehow the experiment lost half the energy of the cart, but you won't show us where half the energy went. You won't show us any indication that it created a bunch of heat and a bunch of sound and a bunch of anything to explain where half the energy went. Just like he won't draw a lever. Even though I've asked him for 2 years to draw a lever and explain how they work, he won't do that. Alright, so in that context, let's watch another piece of shit, snarky, crappy, stupid, moronic video about how Gary's supposed to do all the experiments because science is incompetent and can't do it. So Gary has to save the day and show up like super experiment man and do all the experiments that regular physics hasn't done for 300 years. They've been arguing for a theory, defending a formula, and they show us physically nothing. Just like their silly Young's double slit experiment, when it's kind of obvious that under Young's conditions of infinitesimally small slits, there is no double slit pattern. It doesn't happen. Doesn't exist. It has nothing to do with any double slit pattern or any double slit experiment, really, because you've basically destroyed the meaning of the surfaces. Their existence has become moot, and all you're doing is showing us a single slit pattern. Doesn't matter to these liars. Okay, those facts don't matter to these liars. These defenders, these propagandists, these misinformation, the putting the scale, putting the anvil on the scale and then dragging the scale across, letting a treadmill go underneath the scale. Why don't you do that with your lifting object thing and see if it makes any difference? I mean, it was just so ridiculous. Oh my God. How he gets away with that kind of crap. And he does get away with it because there's this little group of self-supporters who just keep saying they can keep doing this shit, okay? And it just doesn't matter how many lies they propagate. They just have no conscience, no integrity, nothing. Can you express the energy of a spring that has shrunk X meters in an equation? Well, they've already done that. It's Hooke's law. I don't know what the equation would be. The equation is basically that it's linear. So whatever the distance of the spring's compression is, it's in multiples of units. So twice the compression, twice the weight. I mean, we already know that. So, well, what do you want me to say? Yes, if something weighs twice as much, it'll move this needle twice as much. And it'll do it because the spring inside is doing exactly that. So, whatever. Hey, morning, well, whatever, all that crap. In the little universe, as you move in a direction, the force mv is the only thing that is happening. I'm just saying that's an abstract argument. So, look, I don't go ahead, yes. Okay, the only universe is the small universe, but there's no point in attempting to validate the fact that the small universe works like the big universe in the sense that it's just things banging into each other. Because most people really don't understand the thing. They don't even understand what empty space is. So all of that's going to just go way over their heads. Better to just stick with the argument that they have no experimental evidence to validate their claims, and that their claims can be shown in a model that they don't work. That I could make a perpetual motion machine if their physics actually worked. Now, I could certainly make a free energy machine out of simple levers and pendulums. All right. So, on to the video. Oh, eek. All right, check the volumes here. That might be enough.
I don't understand your reluctance, Gary. You've been telling us for months.
Where did I show that I have a great scale? It's got precise measurements. Where did I show any faculty or ability to sit there and use this crappy scale to drop things of different masses and catch exactly how far the needle goes and all that crap? Where? And again, why should I have to do it? You don't have to provide any reasonable evidence for your theory, right? Okay, we're all sitting here saying, link me to your leader, link me to your evidence. So you're claiming this 1/2 mv squared, and yet you will show me no physical experiment. So you've done nothing with the 10-ton trains. It's all just theoretical. You tell me what the answer is, right? I mean, I can certainly show the carts, okay, and you add the extra weight and it comes out exactly with, you lose a tiny bit of momentum, and that's it, okay, half the velocity. Twice the mass, half the velocity. I can show Professor Lewin saying it over and over again. The twice the mass has to go twice as fast. I mean, half as fast. You have to conserve the momentum. So I can play that over and over. Is that what I should do? Is just play the confirmating experiments over and over again until you counter them with some sort of reasoning? I mean, I have referenced the Mythbusters video. I mean, why didn't the cars compress anywhere close to your theory? I mean, it's as far away as it can get. It's almost a perfect illustration of conservation of momentum. Almost perfect. So where do you have to fulfill any obligation? I'm just saying, you're defending a 300-year-old theory. Why don't you show me the evidence that convinced you? The real experiment that convinced you. I mean, I've dissected the ones that are shit, braking speed and rolling distance. I mean, I've already pointed out how that's not the truth. That's not a measure of energy. Okay, and I've drawn the damn gravitational argument. Do you really still think it's not about how much time you're in the gravity being affected by it? You really think the gravity doesn't happen per second, in units of seconds? You think Newton was wrong. It's not a per second force, it's a per foot force. You really think so? I mean, I've done this over and over. There's no answers, there's no response. He just keeps doing this kind of shit. Gary should do all these experiments. Why? Again, why? I've already done, like I said, I did the ballistic pendulum experiment, satisfied myself that it doesn't work, okay, that I don't get this increase in energy. And then I have a lever hanging up over there, so, a balance, sitting there perfectly balanced with one weight on one side and 4 weights on the other side, and it's perfectly balanced, 4 masses. What? I can oscillate any time I want, and it oscillates perfectly. Why don't you explain how that happens? Explain how the energy isn't being transferred to the 2 sides by gravity. The spring is basically gravity. And that somehow gravity knows it has to give twice as much energy to one side than it gives to the other side. Somehow it knows how to do that. But you won't do any of that.
Of this experiment you did in your basement where you dropped one mass on the scale and then you dropped it at twice the velocity, the same mass. And
at 4 times the height, yes. So that I could do to my satisfaction, okay? So I can do it right in front of you again. But yes, I wanted to find out how fast. So first I found out that to make this weigh twice as much. Okay, so it weighs whatever, just one little thingy there. To make it weigh twice as much, I just drop it from 1 centimeter, and it goes down twice as much. Okay, and so then I started doing it different heights. Okay, so I drop it from this high. Let's say something I can do 4 units more of. Okay, so it bounced a certain amount, and then I'll drop it 4 times the height, and I'll find that it went twice as much. So that's what I observed, okay? I didn't publish it as, this is the physics experiment that proves, because, yeah, it's kind of a shitty experiment with a shitty little scale. But to my satisfaction, it answered the questions I had, okay, regarding confirming what I already thought was the truth, and it confirmed what I thought Hooke's law meant. It confirmed what Galileo talked about. It confirmed what Newton talked about. So to me, I'm satisfied until you show me some other evidence. Yes, I'm satisfied, but it's not. I'm not. Again, why should I be doing the experiment with a rickety scale, no high-speed camera, and all of that crap? Why? Why is that what the world needs?
It read twice the weight, twice the energy, as you say. You were quite keen.
Yes, twice the weight. You double the weight by going 4 times higher, because that doubles the velocity, which conserves the momentum. So again, all the physics professors say you have to conserve momentum in all of these closed type systems. So you show me where you're doing that.
On talking about this experiment, saying how much it satisfied you that it's correct. So, as every experiment I do is either rubbish or a cheat.
Yes, that's all you're made out of. Okay, I'm sorry, but you did this dropping thing. I pointed out these obvious defects, and you still didn't make a video showing us. You don't show us the goddamn springs. You don't show the base they're connected to. You don't show the launching device. You don't show a fucking thing. You don't even have a regular goddamn ruler behind it that actually has real scales to it. You actually admit, don't pay any attention to the lines I have because they're not proportional. So you provide absolutely nothing to make the experiment at all credible. Nothing. Fuckhead.
I thought, well, I better stop doing them. And I thought this really simple one that you're already doing and using its result to try and convince people.
So I'm not using it for that purpose, right? So I really haven't in any way used it for that purpose. I haven't at all told people, oh, here's my experiment, here it is, here's the video of it again, blah, 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 blah. I've stated this is what physics says, this is Hooke's law, it's all perfectly consistent, and yes, I did for my own satisfaction drop a few things. And I'm saying if you claim otherwise, show me otherwise. So I'm saying when you roll something on a surface, it doesn't reach half its velocity. That is, it doesn't lose half its energy till it's 3/4 of the way down the track. So just show me an experiment where that isn't true. That's all your obligation is. I'm saying that's what the physics says. That's what Galileo says. That's what Newton confirmed. So why are you playing this game that you have evidence when you haven't shown me any evidence? And I said, for my satisfaction, when I did it simply, okay, gravity is the same going up as going down. Okay, well, there, I'll do the experiment, and I'll say, yeah, it looks pretty much the same to me, okay, yeah. That experiment should be the experiment. It feels the same to me. You did that. You said you were telling us how much pressure it feels. Oh, it feels like 10 times the pressure. It feels like... I mean, if you think that's what physics should be, science should be... So I'm just saying, it's a 300-year-old theory. Why can't you prove it? Why can't they do the Eddington experiment from space? I mean, 400 times better resolution. You can do it with a GoPro camera, and it only takes 5 minutes, and you don't need an eclipse. I mean, why the fuck hasn't this experiment been repeated from space? Do you have an answer, a rational explanation for why one of the most famous experiments in the history of science hasn't been repeated in an environment where you have a gigantically huge advantage? You won't answer the question because there's no good answer to the question except, gee, I guess they're evading it.
Or something. I thought, well, try this one. All you got to do is get a half mass weight now.
So he's making the same video,
and drop that at
right?
twice.
He's making the same video again. Yes, I understand your experiment. You already did it. Just do your own experiment, validate your own results. Go ahead and validate your own opposite conclusion, okay? That twice the compression in the spring creates something less than twice the velocity. Amazing.
That's the velocity. They should weigh the same. It should have the same energy as the one mass.
Yes, 4 times the height, twice the velocity, conservation of momentum. So again, that's what he's arguing against. So he's arguing against Professor Lewin, and yet he's making the video to me. So he has discovered a fact, okay, that momentum is not conserved, and the specific argument is springs don't conserve momentum. So in spite of what everybody believes, and it is almost everybody, right? 99% of physicists will tell you, no, you have to conserve the momentum. You have to conserve the weight, however you want to put it. He's sitting there arguing that he's got the truth, and he's directing it to me. Why are you directing it to me? I'm the one arguing, defending the conventional theory here, you moron. I'm defending conventional physics. Again, everything they say. Julius Sumner wrote it on his board. Big M, little v. Big V, little m. You have to conserve that. You're pointing out that you don't have to.
I've got a suspicion you're reluctant because you're worried that they won't weigh the same.
So again, this idea that I've been doing this for 10 years and that in the last 2 years I've been exclusively ragging on this subject. I've been offering people thousands of dollars to debunk me. Thousands of dollars. I mean, it's not a small amount of money I've offered. I offered Thunderfoot and Veritasium $4,000. Steve Mold, $4,000. Come on, it's not an insignificant amount of money. To make a fool out of me, to show me how, I've just totally fucked up and I missed this super easy experiment. Here it is. Here's the link to the video. Completely debunking the Mythbusters. Completely debunking every piece of argumentation I've provided. Completely debunking my argument that pointy things penetrate further than unpointy things. Yes, that's my theory. That if you shape an object, you can make it penetrate further with the same energy. That's my theory. The shape of the object will decide how far it penetrates. Yeah. Okay, go ahead and prove that wrong. But this is just such horse shit.
And you're worried about how you're going to explain it.
Clearly, I'm not at all worried, but I'm just saying, okay, so this is part of the game they want to play, is that somehow I'm not really confident. I mean, my simulations turn out exactly as I predict. Things are working so well. Everything's going smoothly in terms of the arguments are just getting cleaner and cleaner and more pointy. And everything's going my way in terms of being able to illustrate the point that you're just free energy nuts. And you say I lack confidence. That I really don't. I'm really not confident it'll come out my way. Yeah, I really am. All you can do is do it wrong. If you do it right, it'll come out right. But you're not capable of doing that.
If they're not the same, I think, really, Harry, that you should man up a little and bloody film the damn experiment in your basement and show us all.
Why? Again,
Put your money.
Again, why? You've had 300 fucking years to provide some evidence for your Jesus theory. Okay? I'm just arguing your theory. I'm arguing you're not right. What you're saying is bullshit. And so it's your obligation to show me. And you're saying I have to show you. So I, the one person, have to do these physics experiments, but you, the gang, don't have to do any of them. You don't have to do the Eddington experiment. I have to do it. That's what you're saying to me. And I'm saying, why the fuck would that be the rule? You have the equipment, you have the scientists, you have the lab coats, you have the laboratories. I'm supposed to do the experiments. You don't have to. And again, we've seen what you've done with your laboratories. Again, go ahead and dissect how Professor Lewin wasn't full of shit in terms of his claims about the weights of the carts. Amazing bullshit.
Where your mouth is. God knows it's a big hole to fill.
Yeah, whatever. So, completely valueless, right? He already did this video, okay, yesterday. He already said, here's my experiment, you do it. He has the equipment. So I guess that's what this is, really. This is some sort of gotcha. So he's going to sit there. He already did the experiment. Now he's playing some gotcha thing or something. I don't know. I mean, what's your speculation? And why exactly would he redo the same video over again, in spite of me pointing out that I don't have anything here that's going to make doing great scientific experiments a high probability. So there's absolutely no reason for me to be doing the experiments. None. I mean, you can see, look, I have a background because I don't have a, this isn't a studio or something. This is a little tiny bit of space I have to operate in. There's no experimental layout somewhere where I can just go to a nice clean surface and just set up my experiment and do my little experiments. It don't exist. But anyway. Nice one, mate. So he says nothing, okay? He's proposing a theory that basically debunks Professor Lewin. So let's understand, it's a huge debunk to MIT science. It's a huge debunk to everything in the textbooks. So all the textbooks say you have to conserve momentum, okay? So if you have a system that doesn't conserve momentum, you have to explain where the energy went. So he's saying that when I drop the half mass, I'm not going to get... from 4 times the height, it's not going to go twice the velocity, and I won't conserve the momentum. That is, if I drop a regular 1 mass at a quarter of the distance at 1 velocity, it will not equal the same compression in the spring as the half mass dropped going twice the velocity in gravity. So we know that that's how gravity works, okay, basically, that it does doubling the mass in 4 times the distance. So that is such a huge giveaway. 4 times. Why should it take 4 times the distance? If it's a per foot force, why isn't it 4 times the velocity? I mean, you know, it's a logical question to ask. Why is it only twice the velocity? Oh, that's right, because there's only twice the time in the gravity. And you have to wait for gravity to do its work. It takes time for gravity to apply its force to you. All right, I would like to see Gary do this experiment, showing the results he claims is a fact. So I'd like to see you do your experiment, showing your results to be a fact. So you first. Okay, nature is nature. Okay, so we've heard about what fucking Feynman said about nature, and that it can't finagle momentum. Yet this asshole is overtly saying, yes, it can. Nature can finagle momentum. Can finagle the fuck out of it. So he's overtly claiming Lewin is misinformed. And he doesn't have the courage, he doesn't have the dick to do it overtly. To say he knows Professor Lewin is misinformed. Say it, you coward. Say it, you fucking coward. Because Lewin doesn't believe what you're claiming, you coward. Okay. So let's see your claimed results happen in reality, Gary. Well, let's see your claimed results happen in reality, Fallhead. Okay, let's talk more action and show us your evidence. Right, so I've been sitting here for 2 years saying you have no evidence. You have a clay experiment and rolling things in friction. Besides those 2 experiments, you have no experimental evidence. None. 0. Every other single experiment on Earth, okay, does not confirm what you're saying. Even Brozo couldn't make your results come out the right way, and he made free energy when he used a lever, okay, to launch billiard balls. He actually made free energy. All right. Rather than your belief in your truth, your faith, whatever that is. Belief in your faith? You can't even write a rational piece of Those words cannot be used in that order. Faith becomes a belief. There's no belief in faith, you retard. God, you're a retard. An idiot. A moron. Let's see if there's any other morons available. Look at that. Man, thank you, YouTube. I tried this experiment myself yesterday where I dropped a cube of clay. So, what a fucking idiot. I mean, what a fucking idiot. The last thing you want to do is drop something that fucking goddamn moves. If the clay will squish, it's going to absorb the energy. The squishing of the clay will absorb the energy, you fucking idiot. You have to use non-compressible materials, you stupid fuck. God, I can't believe how dumb these idiots are. From 1 centimeter height and half of it from 4 centimeter height. I have to be honest, the weight was roughly the same for both. Yeah, so even using a squishable substance, which is not the ideal, it still came out right. Problem is, the scale pointer vibrates extremely fast as the weight lands on it. But guess what? It's not that fast, right? We're not talking about stuff going 50 miles an hour. It's only going like, 20 miles an hour. So it is filmable. Because frankly, I did it, okay? So I did it. I mean, yes, as bad as my camera is, you could watch per frame the little scale needle, and you could watch basically the maximum compression. You could find it in the frames. It's not that hard to do. Let's see. So looking at it with 30 frames per second in slow motion makes it difficult to determine the exact maximum weight. Well, you can basically approximate that, it's a big difference. Okay, half the deflection versus, you know what I'm saying. 6 ounces doesn't, you're going to be able to tell the difference between 6 and 12. I have the footage. We'll upload it soon. Okay, so whatever. I'm not going to take this as good news. I mean, Dispar doing the video. So yeah, I'd roughly first say, yeah, clay, bad idea. You want to do something that sticks, but you don't want to do something that deforms. But whatever. Frankly, even if the rebound is what you're expecting, so it doesn't even matter if it doesn't stick. The point is, what's its impact weight? That's all you're trying to detect. How much impact weight did it have? What's its maximum pressure it applied to the spring? Alright, so that's not all bad news. So Dispar is pointing out, to be honest, it looks like it's exactly the same energy. Okay. So we know that dropping the mass from 4 meters gives only twice the energy as dropping from 1 meter. So they're saying that. So we know, I don't know why he has that in quotes, so can you figure this people out or not? That dropping a mass from 4 meters gives only twice the energy as dropping from 1. It only takes twice as long in the gravity. So the dropping part is you're just saying how much energy am I applying? You're applying 2 units of time, not 4 units of time. And gravity's in units of times. I don't know how to get that through your fucking moronic head there, Chris. But gravity comes in units of time. Alright, 1 mass. Because the energy detector, the scale, so I guess he's mimicking my language. Clearly, the scale, in my opinion, is an energy detector because energy is just about applying pressure to things. Everything that has contact in the universe has contact because it's applying pressures to each other, and the unevenness of the pressure is what will be negotiated mathematically between the objects. Shows twice the weight. So he should put this whole statement in quotes, I guess, if he's saying that's my claim. What if we drop it from 4 meters onto a scale on a shelf at 3 meters? What sense could this possibly make? Who cares? As long as the shelf isn't going anywhere. You're talking about the distance it free fell. Again, you don't understand that gravity only gives you energy while you're free falling. Well, I'm not free falling, So this battery is being given weight by gravity. The weight is clearly being absorbed by my body. Clearly. I am absorbing the weight, okay? I can feel it. It's going right from gravity into this object and then right into me. This object is now inert in a sense. It's just another piece of me, okay? I'm absorbing the gravity. Oh, they're all so fucking dumb. All right, that shows 1 unit of energy. Okay, what if we drop it from 4 meters onto a scale on a shelf at 3 meters? How could that make any sense? So you go 3 meters up and then you go another 4 meters up and drop it. So you went 7 meters high, you dropped it to 4 meters high, and somehow you're making a reasonable argument about something 3 meters high. I don't know. It shows 1 unit of energy. Then drop it from 3 meters onto the scale at height 2 meters. That gives another 1 unit of energy. Repeat more until you get to around level. Again, that's 4 times the time. If I go down the staircase, it takes me 4 times the time. Okay? So obviously I'm getting 4 times as much because it's 4 times the time. You can't use the argument that you can get more out of it. You're just saying that yes, if I take a longer time to go down the stairs, I can drag out the units that I get the gravity in, but I'll never gain velocity. So by not gaining velocity, all right, you won't be able to gain momentum. One guy hitting a scale and then another second guy hitting the scale, okay, in different times isn't the same as both people hitting the scale at the same time, hitting the door. That won't knock the door down, right? If I want to knock a door down, I can't hit something elastic and then wait, and then hit it again and wait. We know this whole tipping point thing works. So if the energy comes at the same time, it'll do more work. But it has nothing to do with it having more energy. All right, we have collected 4 units of energy, 1 on each of the 4 scales. So again, I've already been through this one over and over. All right, that's 4 units of energy from 4 times the height. There are 4 units of energy, but no increase in velocity. Even better, use 16 scales on a 16 equally spaced shelves. Each one collects 1/2 unit of energy. Yeah, it's true, but it does it really inefficiently. And that's the fact. I mean, if it worked, you could make a free energy device. You can't. So it doesn't work. Because it's really inefficient to start, stop, start, stop, start, stop, start, stop. All right, each time we divide the same height into 4 separate drops, we double the collected energy. Finally, we have free energy by using Gary's energy momentum discovery. No, we have free energy based on your theory. Okay, that twice the time is 4 times the energy. Twice the time in gravity is magically 4 times the energy. Somehow, the thing has magically 4 times the energy, even though it was only in the gravity twice as long. That's your magical theory, fuckhead. So again, I mean, we already did this, and they just keep repeating it. I mean, I can just keep pointing out over and over again. I can lift this onto a scale. It weighs. I can lift a second one onto the scale. It weighs twice as much. I didn't do 4 times the work. I only did 2 units of work. How can it be 4 times the work? Can't be. Fuck. It's like, like I said, they have no obligation to respond to anything I say, and that's the real problem here. Is to just keep ignoring the counter arguments. Gravity is a force in units of time. Yes, that means that it's meters per second. So again, he's quoting me, but he won't put it in quotes, which is really dumb. So the more we slow the falling down, the longer it gets to free fall. But that's exactly the point. It loses the energy because you keep extracting it by hitting it against a surface. So all the energy it's gaining, it's losing. Okay, Galileo did the ramp thing, okay? And the whole point was to slow gravity down. But the price of slowing it down is you don't get to collect energy because the time units are being absorbed by the friction units. You're rolling it, okay, on a surface. Friction's absorbing the gravity that you're gaining by doing that. Okay. Falling down the longer it, okay, per second. So the more we slow down the falling ball, so if you have to slow it down by causing friction, friction is subtracting energy from the object, moron. Okay, the longer it gets to free fall. So there is no free falling, frankly, in the sense that you keep stopping it from gaining velocity. The more raindrops of gravity it collects and the more energy we harvest from it. So he's just saying the same thing again, okay, when, again, these arguments have already been counter-argued. That, yes, it would be theoretically true if you could take out all the inefficiencies, but you can't. It's insanely inefficient. All right, this is truly Nobel Prize-worthy stuff. So again, I'll just say again, twice the time in gravity, 4 times the energy. That's Nobel Prize stuff. No, it isn't. It's retard. All right, so we redid the Falwell comment. All right, so it's hard to believe we have to go over it and over it again, but so I could redraw that scenario and just keep pointing out that this isn't what you can't make a water wheel that inefficient and have it work. So the fact is you have too many moving parts in your dropping staircase theory, okay, to acquire twice the energy. Doesn't work. I mean, you end up with twice, but you don't end up with 4 times. I mean, it's intuitively reasonable to understand that if I drop something and stop it, and then it has to restart, and then it has to I stop it, and then it has to restart, and then it has to restart, that it's never going to gain velocity. It's always just going to be stuck with whatever, 10 miles an hour maximum. 10 miles an hour maximum, 10 miles an hour maximum, 10 miles an hour maximum. That doesn't equal 40 miles an hour. You're not applying the force at the same time. Where if you allow the object to drop and it gets up to 20 miles an hour, dropping 4 times the distance, all of that energy happens at the same time, is applied to the object at the same time. You can't apply the force to the object at the same time when you drop it in increments over time. So if you don't let it free fall, the impulse will never be at the same time, and it needs to be at the same time. The 2 batteries need to be on the scale at the same time to weigh twice as much. They can't weigh twice as much if they're not on the scale at the same time. But whatever. Morons will be morons. So, I don't know if we want to go to the Dispar Lab video. He's just such a jackass. So we'll do some comments and we'll see if that's necessary. See if he posted it. I don't know how long ago he posted that comment. Let's see. 7 minutes ago. Yeah, so the video's probably not there yet. All right. All right. Oh boy, an Ryan Gosling video. Salutations. No, I don't live with all that, without any of that. While listening to an Ryan Gosling segment, he demands evidence, yet the burden of evidence is on the ones that state it's real. I think the burden of evidence is on the people who have the billions of dollars, the hundreds of thousands of laboratories, the millions of technicians, and the multi-million lab coats. I think the onus is on them to do one of these experiments, right? One of them? Yes. With 300 years of KE, there should be evidence to support KE. Well, I'm just saying, and the biggest piece of evidence, right, would be the 4 times the fuel to go twice as fast. So that's their belief. They have that as, that's their cornerstone. So you're saying, why the fuck wouldn't they prove that? Because it's such a dramatic statement. You know, that you really never want to do anything fast because, boy, do you really pay for it. 4 times the energy to go twice as fast. I mean, that just sucks. So everybody who's environmentally conscious really should say we should have a 30-mile-an-hour speed limit. Nobody needs to get anywhere that fast. Come on. There should be something Ian Gosling can say. This shows KE in play. Right. He should be able to cite some other experiment besides the 1700 clay experiments, which I've already pointed out. There's nothing surprising that pointy things penetrate a surface better than non-pointy things, right? So that's my big counter argument, that pointiness has something to do with how far something penetrates a substance. So that's my counter theory, right? They say pointiness doesn't matter. I say pointiness does matter. It's really the whole subject, frankly. The whole thing. You want to figure out how far something's going to penetrate into a substance? How pointy is it will be a big one. I think there's actually a video in one of these things, where they throw a needle through a piece of glass. I'll have to show that video. But anyway, too stupid, right? So obviously the 1700 experiment is shit. All right, and then I pointed out how the rolling break distance question really is just about how friction takes energy from an object, and that friction isn't linear. Friction isn't the same at 300 miles an hour as it is per foot at 30 miles an hour. So if you're going 30 miles an hour, you're losing a lot more energy per foot, okay, than if you're going 300 miles an hour. All right, so there. That's it, though. They don't have anything else. Nothing. Yeah, nothing. All right, I don't know. These people have no. I don't like how these people have no respect, let alone the scientific method. They don't care about science, right? So all they really care about, because if they did, then they would be like, holy shit, I have evidence proving Professor Lewin wrong. I should tell Professor Lewin that, he's teaching those kids he's teaching them so wrong. Teaching him about conservation of momentum? No, momentum isn't conserved. Kinetic energy is conserved. I mean, if they really believed any of this crap they're spouting, they'd want to fix the world so it's consistent with the truth. They would worry about all the people claiming something else. And it's just directed at me, right? So this is all about the fact that I have a penis and they don't, and they resent it. Especially one that works. That's the part they really, even when they have something that's a faux penis, they can't really make it work. Okay, all Ian has to do is prove KE is right. All he has to do is show us taking 4 times the fuel to go twice as fast. So go ahead and show that. I guess he is, in a sense. He's saying that springs do this. Okay, it takes 4 times the pressure of the spring to get twice the velocity. I have to compress the spring 4 times as much to get something to go twice as fast. That's what he's basically said he demonstrated in his video. And they can't do it. It's pretty laughable. Yes, KE is comparable to the Bible. Yes, it's a religious story. It's a story. And they have 0 evidence for it. They just say, I like to think, and I believe, and with faith comes confidence, and blah blah blah, or some kind of crap like that. But yes, they don't need to see it. They're not saying show me. But this is true about everything, right? They said they did it and found gravitational waves. Nobody really required them to show them much. Here's our little squiggly line. See the squiggly line? Yeah, that proves it. Just because it's an old story doesn't make it true. Okay. It's not even that old, but, it's not as old as religion. But the fact is that they never had evidence for the theory, okay? It never got past the counter-arguments. There was no counter-argument demonstrate how if you believe in one theory, the other thing becomes free energy. And if you believe in the other one is free energy. They never resolved the fact that the conflict is decisive. If you believe in kinetic energy, you really can't believe in momentum, because momentum isn't conserved. Right, that gives them the skewed perspective and not realize that they're the ones that are obligated to do experiments. Well, frankly, science is obligated. I don't want amateur experiments, personally. what we all should do if we cared about science is we would all plead with the institutions, right? We'd plead with these, like this other science, this guy who's an actual teacher of physics, I think. That's his profession. His real world profession. And these are the people who should be fixing the physics. These are the people who, the plea should be made to that please do these experiments. Commission these experiments to be done. These are important truths to dissect. So do these experiments rigorously and to the highest quality standards and prove the truth. Right, that gives them the skewed perspective and not realize that they're the ones that are obligated to. Okay, sorry. So again, we don't want them to do the experiment. We want professionals to do the experiment. People who understand what a quick release is. All right, you have a cool profile picture off subject. Okay, thanks. Well, I guess I'll have to go see what that is. It doesn't look that cool to me. Looks like a human. I don't like humans. Hey Gary, what do you think of hydrogen fuel cells? Are they the future? They're convenient. That's it. They don't, Besides that, I mean, obviously, if you've got confined space, like in space, for example, they have to use them because it's the cheapest kind of, economy-wise, space-wise. It's a great power source. But again, you want to play with hydrogen? I don't think I want a hydrogen tank, sleeping next to me. But whatever. There's ways you can do it to mitigate against, you could bury the hydrogen and then have a little line and just use the hydrogen as you use it. And so there's different things you could do to make it, fairly fail-safe. So, yeah, but it's not like it's magic, It's not like it's a cheaper fuel. So, I don't know, I guess I don't know what you want me to say. Obviously, until we find a free source of hydrogen, where you don't have to burn the atmosphere or burn water to create it and to contain it, it's not going to beat oil. So I guess I can't say I think it's the future. It could be part of the future. Anyway, right, these people are real, with real resources and power, should be doing the work. Although Ian Gosling seems to act like he knows it all, I agree that the evidence we want to see is done in high-quality labs. Well, at least you're conceding that it should be done. Why should the evidence be by insane advocates? So let's understand he has a huge bias. This was the whole problem with the Eddington experiment, right? I mean, part of the problem was Eddington was only one of 3 people on Earth who understood or advocated for Einstein. Most people hated him, especially in Britain, because of the whole German thing. So, he had a huge bias. He was putting everything on the line, in a sense, spending all this money to prove Einstein right. Now, I suppose it's true that he sort of shenaniganed the British institution because he sort of gave them the indication that if we go do this experiment, we can prove Einstein wrong. So he got the money in kind of a backhanded way because he basically was telling the British, well, look, we can prove Einstein wrong by doing this experiment. Right, but you have to understand, why would the British finance an experiment to prove Einstein, a German, right in the midst of World War I, right? I mean, it's pretty hard to explain that exactly. How it would be to Britain's advantage to prove Einstein right. So that's history has all kinds of little crap in it, where you're just saying, I sure wish they would tell me the truth. I mean, as a kid, they told me the Boston Tea Party, and it was a tax revolt and blah, 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 blah. And the tea in the harbor was the cheaper tea, right? So it wasn't about how much you're paying for your tea. It was about a trade war. And it was about how the colonists wanted to control the market. They didn't want the British selling their cheaper tea. It just sucks about how, the truth gets so easily obscured by the bullshit. Alright, so I guess we'll... What video was I going to play? Yeah. Oh, we'll check and see if the Dispar video is up. We'll do that. Okay. That I can do on my own without any help from you. I believe I can anyway. Dispar. Asshole. Alright, so it's not up yet, apparently. Just make sure. Nope, not up yet. Okay. So I guess we will do this. So here's a kid dropping a ball. So I guess we can see that. That might be interesting, right? Kid dropping a ball, different balls, and see which ones bounce more. And we'll see how efficient they are, right? Because I sort of had the illusion, and I mean, I sort of had assumed, I would have never guessed on my own that a tennis ball was only 70% elastic or 75%, in the sense that you lose 25% of the energy. It only bounces back with 75% of the energy you throw it onto a hard surface with. I would have thought it was more bouncy than that. So I guess we'll watch this.
Grammarly Go is the only generative AI product that you need.
Have a Go one.
It's easy to use in the place.
Fuck good grammar. Who cares? Yeah, fuck you. I say fuck you. I don't need to say fuck yes, you yes. I don't need grammar.
Hello at home, Snapshot Scientists. I'm Mr. S.
I'm Mr. S. It's very exciting, Mr. S. Oh, God, it's just so bad. The world is so bad. So obviously he's making videos for kiddies.
Some of you have no doubt taken Snapshot Science as an after-school or homeschool program here in central Wisconsin. Others may be new to Snapshot Science. If you're joining us from near or far, welcome. At Snapshot Science, we practice science by completing experiments that get us to think and do things like a scientist.
Oh, brother. So we wear our little lab coat with our little stickers, and then we draw on our coat, and we put tattoos on it and whatnot. I just hate this baby talk world we live in. I just fucking lying to kids, pretending. Let's pretend we're adults. Let's pretend we're we'll talk baby talk. What are we doing? We just talk absolute bullshit. Fool the little kids into believing we know what we're doing, and we're assholes. All I wanted was to polish my penis, and a kid popped out. It wasn't my fault. I didn't want to have no kid. But I'll pretend. It's all on purpose. I love you. I love you. I love you. Yeah, bullshit. If I'd cure your cancer, you'd grind me up into little tiny pieces. Anyway, what the hell am I trying to do? Oh, it's the volume thing. Okay, that's what I'm doing. All right, so the volume seems about right.
We ask questions, predict what might happen in an experiment. That's called a hypothesis.
Yes.
Observe and collect data, usually by measuring something, and analyze the data to look for patterns. If the patterns are different than what we predicted, we make a new hypothesis and maybe even run the experiment again, just to be sure.
Oh, whatever. You should run it again just to be sure, even if it comes out exactly the way you wanted it to, right? Because there's a 50-50 chance whatever the flaw is, it could be in your benefit, could be against your benefit. So you always have to be careful. That's right. But so you got that logical principle wrong. You do it over again whether the results come out the way you want or not.
We don't need a fancy lab to do science.
Yes, you do.
Science can help us to study just about anything we can think of. In the next few weeks, I'll share at least one experiment per week that can be done with simple items you probably have around the house. This week, Here's what you
Yes, this week we'll do water waves. And we'll say that's what a photon's doing. It's just like the water wave, except the pattern is completely different. Can't you see how it's just like it? Even though the pattern is completely different, it's just like it.
need. At least 2 different balls, a tape measure, stopwatch, or both. Most phones have a stopwatch app. Pencil, data sheet or science journal, and graph sheet. The data and graph sheets can be downloaded from the Snapshot Science website.
Alright, well we know using a stopwatch to measure how fast something's moving up and down a bouncing ball is really not very reliable. So that's sort of bullshit. Alright, we don't need this shit. Get to it already. Fuck this. Okay. Now, fuck it some more. Oh, they're still doing it. I think we're done with that. Oh, fuck. So we don't get to see the fucking experiment? You know, I put up with all this shit and you're just gonna do this music video crap? Fuck. You're still playing music, right? Fuck. I wanted to see the results of the experiment, please. I don't care, the stopwatch thing is retarded. Click! Click! That was pretty close, right? Yeah, I got it right? Click, click! Too silly. So, yeah, I don't want the fucking velocities. I just want to know how high it bounced. So they're not doing the bounce. Alright, so they're trying to measure its velocity instead of measuring how high it bounces back up, which I thought they were going to do. So he seems like he's talking here, so let's see. Oh, I turned the volume up.
Sizes, and they're made out of different materials. And this one is hollow, and this one is solid with different layers of things, kind of like an onion has different layers.
Alright, so we're not going to see what I wanted to see, which was, let's see how high they bounce back, how well they retain the momentum. Well, obviously that's not going to do anybody any good. You want to see how high they go. Oh, shit. So they waste the high-speed camera on
Why
nothing.
do you think that happened that way?
So they're going to show how the kid's retarded and put it in a video. Oh, I dropped the ball. Oh, it was so disappointing. Oh, this was so bad. Okay, so that didn't turn out to be what I was hoping for. Let's see, these other foil things, who cares? Here's the needle thing, so let's do that one.
Sometimes you're settling in to watch a playoff game.
I don't know what you're
you
saying.
get a feeling about a player.
Yeah, he got that look. About to go off like us against Atlanta. Yep.
Hello, I'm Gav. I'm Dan.
Oh dear, I can't understand these guys either. We're English, except we don't do English.
We're the Slow-Mo guys, and this week on the Super Slow Show, it's all about speed.
You could say it's FPS versus FPS. Like feet per second versus frames per second.
Genius.
Yeah.
If not a little confusing.
Yeah, whatever. No, I don't think it's anything reasonable.
We've got a Shaolin monk throwing a needle through glass, we've got a quick draw champion, and we're even splitting some bullets.
Oh, that's not very interesting. I just want to see the monk thing. So this is what they waste slow motion cameras on. So you spend $15,000, $20,000 for a camera, and this is what they waste it on.
I always appreciate it when someone has an incredibly unique talent at one specific task.
Yeah, like my ability to take a football to the face.
You're so good at it.
I'm
You're
quite
incredible
proud
at
of
it.
it, to be honest.
Have you heard about the Shaolin monk skill of throwing a needle through a pane of glass?
It sounds absolutely impossible. How would that even work? It's just
Yeah,
incredible.
it must be like the correct transfer of energy, the speed, the angle, everything must have to be perfect.
I mean, if I was to try it, it would take years. I don't think we've got
How do you know? So why don't you try it? Yeah, go ahead, try it.
that time. But luckily, We've got 3 Shaolin masters with us.
So we know these aren't like sewing needles. They've got to be bigger than that, right? You got to have enough mass, frankly, to create enough energy to go through the glass.
We've got Master Bruce, Master Feng Fei, and Master Liu.
We're just kind of fake monks, you know. We're not. We don't take it all that seriously, this whole monk thing, because we like to do TV shows and be famous for doing our little monkey thing, our discipline thing. I think they're supposed to be concentrating on methods of self-control. They're really not supposed to be trying to be very good putters. You know, maybe we can find a monk that's a very good putter.
So, Master Bruce, how does it work?
So what we're going to be performing for you later is what we call the needle through glass. It is one of the 72 art of Shaolin, one of the highest. Takes, of course, at least 10 or more years to train.
Decade.
Well, what Master Feng Fei is going to do is basically he's going to concentrate his energy to his hand, holding a piece of needle. He's going to throw it as if you were throwing dart, and it's going to go through the glass. And to show you that it actually goes through the glass, I'm going to blow up the balloon. We're going to put it on the opposite side, so when the needle goes through the glass, it actually pops the balloon.
We're going to use the V2511 on this one because it involves glass. Glass breaks very fast, and hopefully we'll see the needle just popping right through.
So there's the $20,000 camera, you know. So let's see the needle, blah, 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 10 years of practice. So this is juggling or something. You know, anything you want. You want to juggle 7 things, you have to take like... I think it's a year and a half per thing you add or something over 3, and so you got to spend like 8 years. So we do all this, whatever.
Bringing the energy to the
Yeah, it's right. The energy. So it's another theory they have, I guess. Is all this antics has something to do with energy. He's bringing the energy to his fingertips.
Diaphragm to the homeland.
Blah, 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 blah. Mystical bibble babble. Why do they bother with this shit? Just throw the fucking needle, retard.
Of course, this takes many years of practice. Anybody could do that, but he's breathing in the real energy.
So this is like the living force. He's collecting the living force. Collecting the living force. Collecting the living force. Okay, so we don't get to see the needle. I would like to see the needle, but it's obviously like a big needle, and it's probably very, very sharp.
Danny, you nervous?
Yeah. About to be a needle go through this.
So it's really just about velocity, right? And angles. So you want to throw it really straight and really fast. And I don't see the needle going through. I guess that's a hole in the glass right up there, maybe? I don't know. Let's see.
Oh, wow. Look at that.
Okay, so obviously we'll see how big the needle is. So it's like a rock hitting something. So if somebody did this like 100 times, maybe 1 in 100, right? So these guys should probably try it, right? See how many tries it takes before they get one to break the glass. So he's throwing it overhand, okay, and he's really close, but you can see it's a pretty damn big needle, right? I mean, a little sewing needle wouldn't be visible, so it's a pretty thick, weighty needle. And it looks like it doesn't hit going vertical. It looks like it stays going kind of sideways, which is weird. So yeah, you can see the needle is not going linear straight. But, so maybe the needle is actually heavier at one end. Don't know. But it just breaks the glass breaks the balloon. So it breaks the glass breaks the balloon.
Oh, wow.
Oh my God.
Did you see the glass move as it hit, as the needle hit the glass, like bowed slightly?
Oh, did it?
Yeah, I think so.
So even with a high-speed camera, this isn't very, yeah. So anyway, so the needle doesn't go in straight, which is, I'm surprised that the mass of the needle isn't behind the point of the needle, because that would really degrade how much pressure you can actually hit with. So maybe each time he does it differently. I don't know. So there, the needle's not going into the horizontal position with all of the mass, the center of mass, behind the point. So that's a real not good thing. So clearly just the glass breaks again, and the glass breaking breaks the balloon. So it's a little pebble hitting your windshield. It's a high enough velocity. Yep, there it puts a crack in your windshield.
Wow.
So it's all the fragments of the glass on the other side that are popping the balloon.
It's crazy that something so light can do that.
Well, you didn't tell us how heavy the needle was. So maybe it's made out of titanium. Be pretty heavy.
So we've repositioned the V2511 behind the glass to hopefully get the needle coming towards, without the balloon this time.
Okay.
That did it.
Wow.
That is without the balloon.
Yep.
So we'll see if it comes. Oh, jeez, that was way too fast. I can't even slow that down. I guess that was regular speed, so maybe they'll slow it down. Can you see any of this? Yeah, I should check. Yeah, you can. Okay. Be funny. All right, so there it is again, and it hits not going with the mass not behind the point, which really is surprising, frankly. You would think it would maximize the impact if the center of the mass was behind the point that hits the glass. You would think, you know.
So powerful. It just hangs, it like sticks into the glass for a minute, doesn't it?
So this is all mumbo jumbo. It's just about mass and velocity in the end. So all of this mumbo jumbo, they should just be saying, let's measure the velocity. So here's the key point. Let's see the impact. So all it is the point of the needle is moving of velocity. It has most of the mass of the needle, I guess you could argue, is behind the needle. So at least most of it is. And all you do is hit the glass and it breaks. So it could be really easy to break glass too.
And even at 28,000 frames a second, that crack is like one frame probably.
It looks really pretty, doesn't it? All that glass shattering like that. It's gone really fine.
Yeah, so lots of momentum conversion. Big needle into a bunch of little tiny fragments moving all kinds of speeds, and if you add it all up, it has to be conserved. So if you add up all the little stuff moving all kinds of little speeds, all of that has to equal the needle going in.
Now we have our host and the man trying to throw the needle through glass. Let's see if he could do it.
Why am I holding the glass?
What do you mean, why are you holding the glass?
What do you mean, what
It
do I
doesn't
mean?
take any skill to hold the glass.
Well, because you look good.
I don't look good and I don't feel good and I'm gonna get a needle through the thumb.
Ready?
Oh, God.
Why
Try
are
not
you
to get my thumbs or temple.
Try put the balloon a bit lower. There you go. Right.
Oh, bollocks.
Ah!
Oh, Dan did a good job.
Did it pierce through the balloon?
Look, I just didn't throw it.
Oh,
right.
You nicked it.
He made a little mark. That's pretty good.
How about that?
You see that?
It's right there.
I just didn't have the right amount of energy. Needed more energy to do it.
That is a face of pure fear.
Oh, look at that. He got nervous and started shaking.
It's scary.
You know what? I reckon it's your fault for holding the glass wrong. Look, you're moving it all over the place.
It was terrifying.
Do you want-
Yeah, so he just didn't have
That was
enough,
nowhere near your hand.
didn't have enough velocity, I guess.
I appreciate you not getting that anywhere near my hands.
Yeah.
I was ready to pull one out of my thumbnail. We really appreciate it. I've wanted to see that in slow-mo for a long time, so that was...
How do you guys enjoy it?
So this must be part of the deal they made, is that you don't really analyze anything. You don't try it a couple of times to see if you could duplicate it without having to do your woo energy dance first. You know, so yeah, maybe it only takes like 3 or 4 tries and then you figure out how to do it. Yeah, maybe. But they didn't show any of that part. So just more propaganda.
Hopefully you enjoyed that video. Feel free to subscribe to the Slow-Mo
Yeah,
Guy.
fuck you, 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 fuck you. Asshole, lying pieces of shit. Propagandizing bullshit, nonsense crapola. Fuck you. I'm not gonna do any of that crap. Alright. So let's see if there's anything else of interest here. Let's see if there's any action in the chat realm. Fuck, I just hate it on this planet. Let's see. Thanks, right. Give them skewed perspective, not realize that a lot can do. Pretty laughable. Okay, oh boy. Okay, we did that part. Let's see. And let's see. It's comparable to the Bible, blah, blah, blah. Alright. Let's see. Right. That gives them a skewed perspective and not realize that they're the ones obligated to do experiments. Right. I think that's where we left off. Okay. Let's see. Oh, yeah. Profit, guys. Okay. Profile picture. Hey, Gary, do you want... Oh, no. We already did that, too. We already did that. Let's see. Uh-oh. It's broken. No, there's nothing here. I should have realized the chatters are retards. Okay, although Ian Gosling seems to act like he knows it all right, where did that? Wouldn't you want the needle to hit the angle like that if it has angular momentum? Well, yes, if it had any angular momentum, but again, you have to realize how slow the angular momentum would be. So it's such a tiny amount of momentum trapped in spinning something. And you'd have to spin it at a very high rate for there to be any substantial angular momentum. So obviously the needle wasn't spinning really fast because we never even saw it do one rotation. So there is no angular momentum effectively. There's just the point of the needle moving a velocity. The end of the needle, the piece that's going to hit, okay, the end that hits. And I'd still argue that it would be a lot more effective if it hits with the center of its mass behind the point. You know, just seems quite logical. Anyway, so we don't have any useful comments from the commenters. I shouldn't have expected otherwise. Alright, we'll do one more little crap video and then get the hell out of here.
So it looks about ready. And it's super squishy.
You're so superly fucking goddamn weird. Anyway, God, I just hate this planet. Hate it, hate it, hate it. Okay, cool water thing now. Lime thing now. We don't do lime things. Alright, the spinning ball thing is interesting, but really not that interesting. Ball pen writing range test. Surprising results. Okay, so I guess he banged on a ballpoint pen. Playing with fire is, you know, fun, but world's biggest ball making, who cares? Alright, 10,000 magic balls in slow motion. Well, this is actually, these little magnets are very interesting. So we'll maybe look at that one. 100,000. So they spend real money.
This one takes me. Experience more with hard-to-get tables from Chase Sapphire Reserve.
Wow.
Chase, make more of what's yours.
Ah, dinner is so important.
Tourists. Tourists that turn into scientists. Tourists taking photos that are analyzed by AI.
Everything is cooler in slow-mo. Like popcorn being popped, cars crashing into a wall, soccer balls hitting your face. It's cooler slowed down.
So these are the two guys just imitating the other two guys. Oh, how cool is that? Oh, shit, 33 million views.
At the point where we're reacting to the coolest slow-mo clips on the planet. And it wouldn't be a slow-mo video if we didn't kick it off with the slow-mo guys.
Whatever.
They are the kings
So
of
this
slow-mo.
is what they waste. This is what they waste slow motion on, is crap.
And I love how silly he looks in that balloon. He looks so happy.
Wait a minute. Is he not wearing pants?
He might be naked.
If he's naked, don't worry, I'll blur it.
Ah, he's not naked.
Yeah,
Okay,
pants.
I mean,
good thing he had pants on.
good. Thank God he had pants on.
That would have been bad if he didn't.
Oh, whatever.
Next clip. Hey, first the balloons
Like these guys would mind.
were filled with water, and now they got paint in them. This guy's face is just getting bullied.
So this is what they waste people's time with.
And a mousetrap.
What would happen?
If I just put my weenie there.
We're not saying you want to, we're just saying your brain has intrusively thought
of it. And thankfully for science, we have slow-mo cameras to test it.
Okay, so to start off with, your wiener.
So yes, to start off with, it's a cooked hot dog. It doesn't matter. So fuck off. Too silly.
He's getting sliced.
Yeah. Wait, is it a clean slice?
It's almost a clean slice.
Almost a clean slice.
That would be recoverable with like...
No, it's a clean break.
Oh my goodness, I should have watched to the end because I would have seen that it was a clean slice.
Now you know. Don't put your weenie in a mousetrap.
So, you know, that's really bad science. Obviously, it'll survive.
I get covered in powder.
Whoa! Bro, this is what I'm saying. Slow-mo is the coolest invention ever.
We would have never known this existed.
I'm just gonna say it out loud, right?
Say it out loud.
Malaria's killed like half the people that have ever lived on Earth, right? Right?
I didn't expect that was what was gonna be said.
But go along with me. And, you know, and we found ways to stop it.
Uh-huh.
This is cooler than that.
Wow, that's a hot
Tell me it's not.
I just didn't see that coming.
Bro, look at that.
Here's the thing. Why
Whatever.
did the universe do that? You know, science didn't know we were gonna have slow-mo cameras.
Yeah, why didn't the simulation just wipe it? This baseball is fired at 1,000 miles an hour.
1, 2,
Wow.
3,
Wow.
4,
Wow.
5.
This is crazy.
6.
Oh, man, the ball is just getting messed up. It's still going.
8.
Does it make the ninth? How will I sleep if I don't know how many baseball gloves it takes to stop it?
If only you had a successful series of YouTube channels where you could test it on any of them.
You're forgetting that in exactly 5 minutes, I'll forget this ever existed.
That is true.
See this car? Mm-hmm. It's jamming into that wall at 120 miles an hour.
This Toyota Corolla is not gonna exist in 0.5 seconds.
It's a Ford Focus.
Hey, focus on these nuts.
Put that in. Boom.
The car decelerates from 120 miles.
I think the car decelerates into a pancake.
With its occupants experiencing peaks.
What occupants? They don't exist anymore. They got banished to the shadow realm.
Skateboarding in slow-mo.
He did a kickflip.
Well, I don't know what all this crap is. I thought they were doing this other thing, and it's got all this other crap in it.
Did you just talk about the country?
That is a country.
Bro.
Dude, I don't know.
What did Myanmar do to you?
I have a child, so I don't...
Shapes?
I thought that was styrofoam.
You're kidding me. No way. Oh, I've seen this clip. Watch this, watch this, watch this. This is crazy. Look at his arm. Look at this. Look at that.
That's insane.
And then he just rotates the ball instantly. Watch.
Ew, that can't be healthy, dog. Firing a 2-inch gun in slow motion.
Oh.
Pew.
That actually work.
Yeah.
I'm never gonna feel safe again now.
If you rob me with a 2-inch gun,
It's washed up.
No, Mark Rober's just old.
Oh, true.
We love you, Mark.
That car back high.
Quite high, isn't it?
I reckon.
I love making fun of British people.
Don't worry, guys. I wore my seatbelt. I would be fine. That's a dog shaking, and now I'm gonna show you it in slow-mo.
It's already...
Don't worry, guys. I wore my seatbelt.
I love making fun of British people.
Don't worry, guys. I wore my seatbelt. I would be fine.
So apparently these guys don't do any of this stuff. They just steal other people's clips, or I don't know what the fuck this is. Don't care about that. Don't care about that. All right, fuck it. Yeah, just fuck it. Ugh, crap. Crap. That's all you can say is crap. Let's close this out. Whatever the fuck, that whole thing was such a waste of time. So this is all this foam ball thing. Shit. Oh, well, just give up. Fuck it. It's time to give up. All right. Oh, God damn it. Hate this planet, hate this planet, hate this. That's where we were. Okay, yeah, that was just such a... Don't touch neutrons. Well, I'm sure you don't have neutrons laying on the table. Worm balls. I don't think I want worms. I don't want to do that. Kinematics. We've already done the cart and ball thing. Yeah, that's where they just shoot the ball up in the air and catch it again. Not too much there. That's very interesting. Alright, we'll give up. Aluminum balls. Okay, so they crush a bunch of stuff in a hydraulic press. Okay, got it. Yes. Fascinating. And such. And so forth. And whatnot. Let's see what this says. A lever in it, but it's no point. Yeah. Basketball run over with a car. Whatever. So this is the eddy current thing. Oof. Yeah, we give... Oh, Dr. Quantum. Isn't that just horrendous? Somebody's put that back up again on the internet. Pile of shit. Sparklers versus a soccer ball. Okay, whatever. Alright, hot things on cold things. Okay, whatever. Alright, never mind. We'll just give up. See if there's any last words from the retard. I mean, the viewers of this channel. The super cool YouTubers. Let's see what the super cool YouTubers have to say. Alright, these guys. What the hell? Did you just... What? Misgender Chris? I don't know, did I? I don't know, did I? Who cares? I don't care. I can be insensitive at times. And, you know... Too fucking bad. I mean, I have real opinions, you know, this whole politically correct thing. I mean, some people are just assholes, and they should be called assholes. You know, and it doesn't matter whether they're trans or whether they're European or, you know, it doesn't matter. They're assholes. I think the slight angular momentum the needle had makes hitting the glass at a small angle a better transfer of energy instead of dead on, because it will continue to spin while piercing it. I'm just saying there's absolutely no evidence in the video that the needle was in fact spinning at any kind of high speed. And it would only be because the needle could be adding speed that it would be useful. The angular momentum can only have a use if it's adding velocity. It clearly wasn't adding any velocity. So, I mean, I'm sorry you want to believe that, but this is not an angular momentum circumstance. It's not the fact that he did a little wrist action or something to spin the needle that makes it happen. It's just raw velocity. He has to move his hands and his fingers, and he has to get the velocity. So he could flick his wrist, but it has nothing to do with, you know, spinning the needle. The needle spinning was not an effect. I'm telling you. You're just not understanding. But for the spinning to mean anything, it has, that rotation has to be adding velocity. And it clearly wasn't adding any velocity. It was spinning so slowly. I mean, that would be another experiment to do. It would be kind of interesting, is to actually create a machine that spins a needle and see how fast you have to spin a needle to make it do the same thing. But there was clearly no evidence of any substantial rotation. I mean, there was just no evidence of it in the the video. The rotation speed was much slower than the linear speed of the whole needle. Alright, 2-minute warning, I guess. You seem all played out, commenters. That would be interesting, right? With all this monk discipline, they really should be able to make like a Tiger Woods, right? So they should, if they applied all of their discipline to, hitting a golf ball, they should be able to do it better than anybody ever did it, kind of thing. But instead, they do things that nobody tries, Catch yourself on fire. I mean, things nobody wants to try. I can do that better than you. But everything is such hype, the whole monk thing. Especially when you see overweight ones and you're saying they're supposed to be able to control everything and they can't even control their weight. Come on, too silly. I mean, even if you can't control your weight in the sense that, your instincts just... Obviously, it's just about how much food you eat. So you just reduce the amount of food you're allowed to eat and you have to lose weight. There's no choice. So, I mean, it's just... That's such a mechanically easy one, to control. Looking back at the video, you are correct. It just smashes down instead of spinning back up when the impact happens, right? I'm glad you agree. So, anywho. It's, again, just kind of sloppy science, right? I mean, frankly. Yeah. Yeah. So, I mean, it would take some practicing to see how fast you can move your hand. Throw my hand. I'm going to try to throw my hand as fast as I can. You could understand that it would take you a little bit of time to figure out the exact right motion to get the highest speed out of your hand. Because you just don't practice that kind of stuff. But that's all it really has to do with is velocity. All right. So, I guess that's... Oh, here we go. I guess the 10 years of practice wasn't enough for the monk to get a dead-on hit. I mean, it is kind of funny, I'm just saying, because, yes, theoretically it has to work better with the mass behind the point of the needle. It can't work less well. So that's all I guess I can say. Maybe it doesn't matter because the velocity is high enough that it doesn't matter what the rest of the mass is doing because the point has enough mass to do the damage. But it just seems pretty likely that it would matter. See, theoretically, right? Let's say if I could, a thought experiment, if I could separate the needle in space. So he throws the needle and then I break the needle and I just have a tiny 1/10 of the needle and the other part is separate. So they're still moving, but I separated them. And now the little point with its tiny mass and high velocity hits, maybe it doesn't need the rest of the mass to actually break the glass. But it seems to me the extra mass would help. Yeah, for certain. But anyway, I mean, what takes 10 years of practice is to make it happen each time, right? So that would be the real test, is that every single time I do it, I get it right. So that would be the real practice thing. That would be what practice enables you to do, is to hit the right keys on the piano, all that kind of crap. because it's muscle memory. And you don't have to think about doing it right. You just do it right because you practiced it. So I guess theoretically juggling's sort of like that, right? So if you're juggling, there's a theory. You know, my hand has to be here, my hand has to be here. And it's really not about knowing the theory. It's the muscle memory. It's exactly getting your hands to actually compensate for the fact that, okay, this one threw it a little bit too hard. And so I'm going to have to catch this one over here instead of here. You know, it's being able to match the two things you're doing. And your muscles have to recognize when you make a mistake because you can't do it consciously in any way. I mean, I used to be able to juggle 3 things. Yeah. You know, and I could juggle any 3 things. So I could take 3 very uneven things and I could juggle them. But I'm not going to do it here because I might break something. But anyway. But yeah, I just don't bother trying anymore even. So anyway, it was a skill that did degrade a bit after I had the stroke. So I never really got back all my dexterity in my right side. It's always been a little bit dull. Alright, so I guess now we're done. Okay, so anyway, I can only do my half of the video. I can't do your, well, I can do your half for you, as I've stated. I probably should. Let's take a day off and just write a bunch of inane questions, and then I can just post all my inane questions. And I can respond to them. Say, you dumb fuck. Alright, anyway. That'll be all, folks. So, till the next time and such, and so forth and whatnot. This has been at draftphysics.com, debatephysics.com also. Video presentation.